Look, all right, I just want to teach you something. All right, compound inequalities. Basically, compound inequalities are inequalities that requires two inequalities. All right. Sometimes you can be less than 2 and greater than -1. Sometimes you can be greater than -1 or greater than 3. All right. Now I'm going to try to show you how to work on that. Oliver, listen, I'm speaking, I'm talking and explaining. And if you're not paying attention, don't ask me a bunch of questions. All right. So here we go. Number 1, B is greater than -1. So I want everybody to put a open circle at -1. And then we're going to go this direction, greater than. Then I need everybody to put a solid dot at 3. And I'm going less than. Now, what I would like to do is I'm going to change this because I want you to see it. All right. So this, the pink line represents everything less than 3. And the green line is going to be anything greater than -1. So everybody see that? Right. Now, what I would like everybody to do is I'd like everybody to look up and let me draw this out. All right. This kind of separates the number line into 3 different intervals. All right. So those are the 3 intervals. Now, we say and, all right? We say and, all right? When you say and, it must be true for both inequalities. Sorry about that. It must be true for both inequalities. So if I take the yellow section, are those numbers less than 3? Yeah. Yes. But are those numbers greater than -1? No. So what I'm showing you is this piece is not part of the solution. All right. Now I'm looking at the green. Are those numbers greater than -1? Are those numbers less than 3? Yes. So that is a solution. That is a solution. Now I'm looking at the purple. Are those numbers greater than -1?
Yeah.
Are they less than 3?
No.
No. So that is not part of the solution. All right. So the answer to this equation or to this compound inequality is just all the numbers between -1 and 3.
So,
All right. Nope. All right. The answer is all the numbers between -1 and 3. Now, what I want you to understand, you got to let me finish and don't interrupt me. All right, what you're trying to do is you're trying to look at this and understand that an and statement means it must be true for both of them. So I would want you, instead of having to graph them every time, to think about it and say, okay, what numbers are greater than -1 and also less than 3? And I would hope your brain would be able to say, okay, that's just the numbers between -1 and 3. All right, that's what I want you to do. If you're having a hard time seeing that, then every single time you should draw the number line and look at the number line and figure it out from there. Now, when we get to advanced math, we say we don't really use number lines. All right, we use interval notation. So underneath it, that's where I want you to write the solution. The solution is everything greater than -1 and less than 3. And notice I have a bracket here. All right. And I have a parentheses on -1. Again, the reason why There is a bracket at 3 is because it's equal to, and because it is a parentheses, it does not have the equal to. All right, that's what I need you to understand. All right. So again, I had to do 4 examples for my other class before they kind of saw it. All right, so that's what we're going to do. We're going on to the next one, number 2. All right. Now, this I would like for everybody to say is the variable Q. And I would like for you to say that that variable is between 2 and -5. Does everybody agree with that? Right. Now, I have a little disagreement here. If I was writing these problems myself, I want you to always write the small number first and the large number what? Second. So we're going to rewrite this as -5. After you write the -5, we have the variable. And then we have the large number. Now, again, this means that x is less than or equal to 2, and x is greater than or equal to -5, which basically means, based off that, that x is between -5 and 2. Now, because you're paying attention, you know that I'm going to put a solid dot at -5. I'm going to put a solid dot at 2, and it's going to be everything in between. Now, to write the interval notation, we're going to do bracket -5, comma, 2, close bracket. All right? All right, what?
Why did the sign switch?
What's that?
Why did the sign switch?
Because I switched the -5 and the 2. All right?
Why?
Because if I say this, if I say x is greater than 2 and rewrite it as 2, you switch the signs.
Oh, I thought you.
All right. All right. Now let's go over again to number 3. X is greater than -3. Put a dot. X is less than or equal to 4. And there's my answer. That's all there is to it. All right. Now, if we want to write interval notation, thank you very much. That is an open circle. Thank you for paying attention. All right. It's open circle because it's not equal to. All right. Now, the interval notation, parentheses, -3, 4. I appreciate that very much. And a bracket, -3, 4. All right. Now, again, I'm going to ask you to do number 4. Let's see what you can do. All right. I'm going to scroll the screen over. While I'm moving the screen, you try to see if you can look at number 4 and see if you can write it properly. Tell me.
Okay, so got bracket -2, comma 4.
You're amazing. All right. And we're just going to graph it. Just because I want you to see that. If you ever have any trouble, all right, graph things. All right. Now, what I would like is everybody circle number 5. That's part of your homework. 6 is part of your homework. Okay. Now, everybody's looking at number 8. All right. Now, that says that 3p is between 3 and 21. Well, I don't care about 3p. I care about p. So if 3p is between 3 and 21, someone tell me what p is between.
1 and 7 respectively.
1 and 7 respectively. All right, now how do we do that? We just simply divide it by 3, divided by 3, divided by 3. So p is less than 7 and less than or equal to 1. All right, does everybody see that? Did you say 3 or did you say? Brian, I can't remember what you said. Did you say 1 and 7?
Yes,
you said
yes,
Yeah.
we're in seven.
Yes, divide all of them by 3. All right, divide all of them by 3. All right, now if you were looking at it, 1, open circle at 7, everything in between. Because we're trying to learn interval notation, we write right underneath the number line.
Yep.
1, comma, 7, parentheses, bracket. All right, Oliver.
Ones such as.
No, we're on number 8.
What,
All right, now we're going on to number 10. All right, now number 10, notice. All right, they're just written separately. So you just have to solve both inequalities. So for number 10, I just have to do what to both sides? The first inequality, what do I have to do? Add 1. That's it. So I'm going to say y is less than or equal to 3. And on the next one, it would be minus 2. Y greater than or equal to -1. All right, so now let's look at our inequality and put it on the graph. Solid at 3, going less than, -1, solid, going to the right. And so our interval notation, bracket, -1, 3, close bracket. Yes, sir.
On nine,
No, I'm not on 9.
I know, but
No, I'm on 10. All right, that's what I'm doing. I'm going down and doing the evens. I did the odds with the other class. All right. Anybody have any questions with 10? All right, here we go. Number 12. Don't be confused. All right. All I need to do first is subtract the 12, just like normal. So we subtract 12, subtract 12. I get -8, less than or equal to 4D, less than 20. Now we divide by 4. When I divide by 4, I get -2, less than or equal to
D, and then, yeah. No, 5.
And now that again just means D is between -2 and 5. Solid dot at -2, open circle at 5. Everything in between,
Makes sense.
bracket, -2, 5, parentheses. Yes, sir.
I think why don't you divide, no. Is that,
Okay.
I think I did different now.
Okay, now a little bit more difficult. All right, compound inequalities.
Okay.
Or statement. All right, an or statement. If you have an or statement, it only has to be true for one statement. If it's true for one statement, it's true for the entire statement. All right, now, in my opinion, the and is easy. The or is where kids have trouble. All right, so please take a look. Let me get through. All right, the first 4 or 5, and then we'll go down and knock out the evens, and you can see it's not really that bad. All right, but this does require a little bit more thought. All right, so here we go. B is greater than 2. All right, so I put an open circle. I'm going this way. Less than -3. Solid at -3. Going to the left. All right. Now, everybody look up for a second. These numbers in between, right here, the purple, do they work for either inequality?
Yeah. No.
No. Yeah.
None of the numbers between -3 and 2 satisfy those questions or those inequalities. So that's not part of the answer. However, if I look at this guy, all right, is -4 greater than 2?
No.
No.
So that works.
Is -4 less than -3?
Yeah.
Yes. So because it's true for one, that is part of the solution.
What?
Now, if I go over here and I look at this part of the graph, is the blue area greater than 2?
Yeah.
Mhm.
No.
Yeah.
Yes.
Is it less than -3?
No.
So a lot of kids make mistakes because they think it's got to work for both. Does it have to work for both? No, it only has to work for one. So the purple, there are no answers in the purple. There are no answers in the purple. All right. So believe it or not, that is the solution to that compound inequality.
Bracket.
All right.
Three.
This over here, if you recall, is -infinity. And this over here is infinity. All right. So if you're going to write the solution, you're going to say, I'm from -infinity to -3. Then you're going to make a bracket. All right. Now here's where I need your attention. This symbol right here is called union. All right. That just means together. These two things are the solution. It's not an and statement. All right. It's a union. These two are the answers. The other part of the answer would be
Two.
parentheses, 2 to infinity. That would be the answer. All right. You got to think, guys. That's why this is harder now. I'm asking you to think a little bit. It's not just memorize the process. All right. You got to think. There's a difference between an and an or. All right.
What'd you say you was again?
Union. All right. That's the symbol for union. It just means these two are both the answer.
I thought two wasn't. Thought two would be.
They can both be.
What?
I thought two's not greater than 3 and 4.
I didn't say it was.
Then why'd you write two and
Because this right here is the set of numbers that are greater than 2. That parentheses doesn't include 2. The parentheses does not include 2. Because what's the first number greater than 2? No. You're wrong. There is no first number greater than 2. So no number could you write there. All right. Here we go. Let's take a look at 14 now. Well, I don't like the way 14 is written. All right. I always like the variable first. So I'm going to go ahead and say that's Q is less than or equal to 3. Q is less than or equal to 3. All right. Now this one again requires a little bit more thought. So I definitely need you to pay attention here. So the first thing we're going to do is we're going to graph less than or equal to 3. So I'm going to do a solid dot going to the left. Now I'm going to do a solid dot.
Okay, Moss.
No, no. You're interrupting just as much as he is. Going to the left. All right. Now, once again, I'm hoping you can see that this kind of separates the inequality into three different parts. All right. Now, if I'm looking at the blue parts, are any in the blue, any numbers in the blue, are they less than 3 or less than 1? No. So none of these answers work. So I'm taking and I'm eliminating that. All right. Now I'm looking at the numbers in the pink. Are the numbers in the pink less than 1?
No.
No. Are the numbers in the pink less than 3? Yes. Is it true for one of those inequalities? So it's part of the solution. It's part of the solution. Now I want to look at the gold. Are those numbers less than 1?
Yeah.
Are they less than 3?
Okay.
Does it matter? Because they only have to be true for what? 1. They only have to be true for one answer. All right. So my answer is from negative infinity to 3. Put a bracket at 3, parentheses at negative infinity. That's all there is to
Take
it.
the one.
No, why not one?
Oh, because it's going toward the.
That's not. One. Oh, it's because of the same part. Okay.
All right, let's try one more. What?
I thought that 3 was a greater than or equal to something. Why did you put it third?
That's because you're saying 3 is greater than. I don't want you to think of it like that. I want you to think of it as Q is less than or equal to 3. Those two things mean the same thing. What you're having trouble with, that's why I don't like to write the variable second. Remember, if I said this, if I said 3 is greater than 1, and I switch it around, you would say 1 is less than 3. Okay, that's what I need you to do. That's what I'm saying. You got to write down. You got to work. All right, no daydreaming. All right, so now I'm on 15. Here we go. Y is less than or equal to negative 4. So I'm putting less than or equal to negative 4, drawing this direction, greater than 0. Open circle, going to the right. All right, so this one's pretty straightforward. I really would like everybody to put the negative infinity here and the infinity here. All right. You always read numbers from what? Left to right. So I'm hoping everybody can look at that and say, I'm going from negative infinity to negative 4. There's a bracket at negative 4, parentheses and negative infinity. Union, parentheses, 0, infinity. Everybody's agreeing?
Yep.
All right. Again, I'm understanding, guys. It's tricky. All right. That's why I'm trying to tell you, you got to work. All right. Can't skip the work. All right. Now, one more. All right. I'm going to do 18. All right, Mr. Hubbard, let's go. If negative 2 is less than X, that means what about X? Shh. Yes. X, switch it, greater than or equal to negative 2. You with me on that?
Yeah.
Now rewrite the next one. Or what?
X is greater than 2.
Yes, that's it. X is greater than or equal to 3. Okay. Now, eventually, like some of you, I just know what the answer is because I just understand numbers. All right. I'm trying to get you that understanding. I would want you to say, okay, if I'm asking for numbers that are greater than negative 2 or greater than or equal to 3, I would want you to be able to tell me, obviously, this is the answer. All right. Now, it's not always obvious. If it's not obvious, you put it on a what? Put it on a number line and it becomes obvious. All right. So the first thing we're going to do is put a solid dot at negative 2. go this direction. Then I'm going to put a solid dot at 3. And I'm going in this direction.
I think the opposite.
Say it again.
I think
Why did the other dot? That's what you just said to me.
no, I said I did it the other way. I switched the dots going to the left and to the right.
You switch the dots going to the left and to the right.
Yeah, because
You mean the arrows. I switched the arrows, the
Yeah.
direction of the arrow.
why do you switch the arrows going to the left?
Because it's greater than -2 and it's greater than 3. Right? All right, now once again, over here is negative infinity, over here is infinity. All right, Jacob, what did you think the answer is?
Would it be since negative, would it be negative infinity?
Shh, leave him alone. I
Oh.
definitely wouldn't listen to him. All right,
Yeah.
so I want you to tell me what you think.
Not 100% sure of this.
Well,
but,
I'm gonna tell you, that's what I want you thinking about. You don't have to tell me that. What do you think is the answer?
Would it be negative, wait, no, it'll be and -2 and then -2 and then infinity.
That is correct. That's how easy this is. -2 to infinity is, do I include -2?
Hmm.
Do I include -2?
Yeah.
That would be a bracket then. Do I include infinity?
Yeah.
No,
Oh.
it would be a parentheses.
Oh.
Okay, now, as he was saying, are any of these numbers, the gold numbers, part of the solution? Are the gold numbers part of the solution?
Gold numbers?
Yes.
No, yeah,
No, they're not.
they're not, but
No, no buts about it. They're not. Are these part of the solutions?
Yeah.
Yes.
Mhm.
And finally, this over here
Yeah.
is part of both solutions.
Yeah.
Right? 4 is greater than 3 and it's greater than -2. So the ultimate answer is everything greater than or equal to -2. That's all we're doing.
Okay.
All right. Now we're going to drop down. Check out number 20.
Why can you not write the other ones?
Why did I not write the other what?
I thought you said the other, like, what was part of
The gold is not part of the solution, so that was crossed out.
the purple one?
Yes, I did include the purple. The purple is greater than -2. Do you agree with that? I understand what you're asking. Do you hear me? So
What?
-2 to infinity takes care of 3 to infinity. Does that make sense?
Not really.
So if I start counting from -2 to infinity, if I count from -2 to infinity, am I going to pass through the 3 and the 4?
Yeah.
That's why you don't have to write it twice. I have some kids, believe it or not, that don't listen to me, but they do this. -2, 3, then they do this, union, 3 to infinity. That doesn't make sense, does it? Right? You see what I'm saying?
Yeah.
All right. They overlap. All right, so you don't have to say it twice. Okay, for number 20. All right, I'm highlighting this guy right here. The first inequality. What do I have to do first? Oliver.
Give I a second, to look at it. Alright, so we're gonna have to do -1, so
Subtract 1.
-3p is less than or equal to -12, or p is less than 12.
What?
Can I rephrase that?
No, I want you to say P is greater than or equal to 4.
Or again, 4 times.
What did you divide by?
I didn't divide by anything yet. I have not divided yet. So I still, First you're gonna do is subtract one from the one, the negative 11 and the 2. Yeah,
No,
Oh.
that's your mistake. These are two individual inequalities.
so before the or is where it's marked off? Okay. Alright, so then you have negative 3p is greater than, that's less than, sorry, I read that wrong. Is less than or equal to negative 12. Or p is less than 2.
All right, so hold up. After you wrote negative 3p is less than or equal to negative 12, you need to divide by negative 3.
Yeah.
When you divide by negative, that means that you switch the inequality sign. So it becomes p is greater than or stop, Oliver. Just stop. It's taking 5 minutes to do this problem. P is greater than or equal to 4. All right, next. P is less than 2. So now you're graphing both of those. P is greater than or equal to 4. So be a solid dot at 4, going to the right. And it would be less than 2. So it'd be an open circle at 2, going to the left. Which means, again, here's negative infinity, here's infinity. So I'm going from negative infinity all the way to 2, union, but this time it would be a bracket for to infinity. Yes, sir.
2 things. If you wrote the 4 and then infinity first, would you get points off and then 2?
Yeah, but I want you to remember, you read numbers left to right, small to large.
And how do you know when you put the infinity before or after?
Here's how I'm reading the numbers, buddy. Watch me. I'm always reading numbers this direction. You with me?
Oh. Alright.
So I'm starting at negative infinity, going to 2, skipping from 2, 3, and 4, and then picking up again from 4 and heading to infinity. That makes sense, right?
Yeah.
All right. So now let's knock out 22. All right. So for 22, again, you're thinking of them as two individual inequalities. So the first inequality, I have to do what?
For the first inequality, you have to -2.
Minus 2. So I'm going to say 2y is less than what?
Is less than 10. Then you divide by 2.
And we have y is less than 5.
For the second one, you have to add 3.
Add 3. So you'll have y is greater than or equal to 2y plus 3. Then what?
Then you -2y.
Minus 2y.
And then you have to you can get rid of the negative sign.
Yeah. And say y is
Greater than or equal to -3. Or less than it.
right. Because whenever you multiply or divide by a negative, you have to change the inequality sign.
Yeah.
Whenever you multiply or divide by a negative, you have to change the inequality sign. I'm listening.
Why don't you change the sign, right? To 5, 1, 5.
Because I didn't divide by a negative.
If you also multiply by negative, you can,
Multiply by a negative, change the sign.
and then you put open circle at 5,
Yep.
and it's going to the left.
Yep.
And then you put a closed circle at -3. Or at whatever.
Yeah, that's kind of dumb.
Yeah.
So here's -3.
And at -3, you put a closed circle and 4.
All right. So this is infinity, this is negative infinity.
So, the answer would just be. Think the negative infinity.
Yep,
And then five. So.
you are
there'd be a-
perfect.
Yeah.
That's perfect, man. Because it would be all of these.
Like that.
That's beautiful. All of those are the answers. All of those numbers. All right, let's knock out 24. Here we go. Tell me.
Three plus two, three, five.
So what do I need to do?
First, we need to discount the two
Right? So 3A, go ahead.
is greater than or equal to, three.
Yep,
We need to divide by the latter three. So A is greater than or equal to, simply one.
1, beautiful.
And then as for the latter equation, seven plus three A is less than two A plus six. Yeah, we need to discount the two A. And we need to subtract the six as well,
Subtract the what?
subtract the six
You mean the,
from both sides.
I move the variable over here, which means I need to move the number over here.
Yes.
You happy with that?
Yes.
Okay, so what am I left with?
One is left with, A is less than negative one.
That's right. A is less than -1. So now, graphing,
So A is greater than one, so we, solid, I got on one headed to the right.
yep,
As for A is less than negative one, well. Solid, an open circle on the negative one.
that's true.
headed to the left.
Okay, interval notation,
We need that, that's going to be, so, so it's for the former problem, while A is greater than one. So a positive infinity, none, or just infinity. And then one more in its own bracket.
yeah, but you have to start from left to right, Ryan.
Oh, yes, I'm sorry, one.
So we're starting with what number?
One,
What?
and one as. opposed to
No.
infinity.
We're starting at negative infinity, right?
Yes,
So we're going from negative infinity to what?
to one,
1 or -1?
the negative one.
Do you agree or not?
I'm not quite sure.
All right, look, that's what I need to hear from you. Do you agree? We got, or you got A is less than -1.
Yes,
You got A is greater than or equal to 1.
yes.
So these are my answers from here to here and from here to here.
I see better now.
Okay, so what would my answer be?
It's for A is greater than or equal to a negative.
Negative infinity to what?
Negative infinity to. Negative infinity.
To -1.
Negative.
Union, bracket, 1 to infinity. All right, now your only job is to knock out the odds, and I'm fine with not doing 26, 28, 30, 32. All right, but I do want you to do the odds. All right. Yeah. Yeah, so we're starting with 19 all the way down to 37. 19 to 37, that's what you're doing. I will be collecting it tomorrow.